Okay, so today we are looking at equivalent fractions. Okay, that word equivalent, look at this first bit, it's the start of equal. Okay, equal, the same. Let's bear that in mind when we look at these. Okay, fractions. Okay, I don't know many people that like fractions. Okay, and when I speak to older people and I say, what part of maths do you find the hardest? Most of the time, people say fractions. But very, very straightforward. Okay, I've got a square. Okay, and I've chopped it in half. These words we hear on a daily basis everywhere, not just in school. Okay, half. I'm going to use a highlighter and I'm going to colour in half there. Okay, so at the moment we have half of that square is shaded. Okay, how about then if I created 4 little squares within my big square? Okay, how many do we have shaded in? We have 2 out of 4. Did I shade anything more though? No, I didn't. I kept that the same. So half is exactly the same or equal to 2 quarters. Okay, so how about then if I cut the squares into 8 equal pieces? How many now are shaded? We have 4. Have I shaded any more of the square though? No, I haven't. How about then if I chopped these to make 16 squares? How many are shaded? 1, 2, 3, 4, 5, 6, 7, 8. All of these fractions are equal. Okay, so they are therefore equivalent fractions because they all are exactly the same amount of the original shape. Okay, or the original amount. Okay, so I had a square, I haven't shaded anymore. You can see it's the same amount. If we were to have all of these 8 pieces here, okay, we would have half of the whole thing. So what we had then, all of these are equal, they could go in any order. So a half is equal to 4/8. Okay, and also 1/2 is equal to 8/16. But let's have a look at the actual digits. Okay, let's have a look at the numerators first. What have I done to get from 1 to 4? I've multiplied it by 4. What have I done to get from 2 to 8? I've multiplied it by 4. Because we've multiplied both the numerator and the denominator by the same number, it would always be an equivalent fraction. Here, to get from 1 to 8, we multiplied by 8. To get from 2 to 16, we multiplied by 8. So therefore, they are equivalent fractions. Let's have a different random fraction. Let's have 3/5. And to make these digits bigger, but the same size fraction though, remember we're not changing any more the square. All I'm going to do is just enlarge each of these digits. So this time, I'm going to multiply this by 5. 3 times 5 is 15. And then the bottom bit, as long as we do the same, times by 5, times by 5, we have equivalent fractions. Okay. How about though, these digits, have been getting bigger. Let's see if we can make them smaller. So let's have 6 on the top, 9 on the bottom. Okay, this time we're going to make these digits smaller by dividing. Okay, I'm going to divide by 3 because I know both of these numbers can be divided by 3 without leaving a remainder or a decimal. 6 divided by 3 is 2, 9 divided by 3 is 3. So 6/9 is equivalent to or equal to 2/3. Okay, let's use that pizza analogy that so many teachers have used and so many pupils have heard. If I cut a pizza into 9, okay, and I ate 6 pieces, it's exactly the same as eating 2/3 of the whole pizza. Okay, it is exactly the same sizes, exactly the same amount of pizza. Okay, now these here, okay, I've used pizzas. Now I'm going to use a different food to show the method for these. Now I refer to this as the burger method. Okay, you can see with the bun on the top and the bun on the bottom. Okay, so a little way to help you remember the burger method. Okay, you will see to make the burger we've got to draw the arrows. Okay, makes it clear for you, makes it clear for the examiner, makes it clear for the teacher. You'll also notice I've used different colour pens. Again, make it clear, make it stand out. Those of us that are visual learners, this will help us. Most of us are visual learners. Okay, different colours help stimulate your brain to help you remember. Okay, so how about then if I had some really big numbers? How about if I had 24 and 36? Okay, now I know what the highest common factor here is. Some of you might not know that straight away. Okay, now it doesn't matter how many steps it takes as long as we get to the simplest form. So here, what's a number that goes into 24 and 36? Well, 2 goes into them, both even. So let's divide them both by 2. 24 divided by 2 is 12. 36 divided by 2 is 18. Okay, divide by 2 is the same as half. Okay, well, this is not simplest form. They're both even, so we could divide them by 2 again to have 6/9. Right, well, 2 doesn't go into those, but if I tried 2 doesn't work, let's try 3. Does 3 work? Yes, it does. This time we're going to divide by 3, which makes 2/3. Do 2 or 3 have any other factors, okay, that are greater than 1? Okay, they're common factors? No, they don't. So this part here is what we call simplest form. It cannot get any smaller, as in the digits can't get any smaller. The size of the fraction, the size of the amount of pizza is still exactly the same. It's just the digits have become smaller to make it in simplest form. Okay, so here then, we could have gone straight from 24 all the way to 2 as one step. We could have gone from 36 all the way to 3. Okay, now that number is 12. Okay, the highest common factor of these two is 12. So we could have just gone 24/36, divide, choose a different colour pen, divide by 12 to make 2, and divide by 12 to make 3. Okay, but some of you may need to do a couple of steps to get there. Doesn't make a difference as long as we get there in the end. Okay, some of you might be looking and thinking, well, we've got a 2 and a 2 and a 3. How does that make 12? Remember, inverse of division is multiplication. Okay, 3 times 2 is 6. 6 times 2 is 12. Okay, simplest form. So all of these fractions are equivalent fractions, equal fractions. Using the burger method, either multiply or you can divide each of the digits. Whatever you do to the top, you've got to do to the bottom. Have a good go, and I hope it helps.